In this module, we're going to take a look at Java's variables. We'll look at the types of variables Java permits, how to declare them, we'll look at how to initialize them, in particular, how we can define literal formats for them. We'll also take a quick look at the normal naming conventions that Java programmers will expect you to use. Let's start by creating a new project. We'll create a regular Java application. We'll call it variables. And then the first thing we'll do is to bring in a number of variable declarations so that we can look at the most common types. The format of a variable declaration is always essentially the same. We start with the type of the variable, then we have a name for the variable. Names should always be meaningful if at all possible. In this case, though, we don't actually have a purpose for this variable other than demonstration. So all I've done is call it a byte. So the name there, a byte, is reflective of the fact that this variable is a byte type. Then I chose to go straight into an assignment. I've got the literal value 127, which is a decimal number in this case. And a byte value is exactly that. It behaves like an 8-bit value. Other types that we can have in Java for numbers, we can have a short, which is essentially a 16-bit value, an int, which is like a 32-bit value, and a long, which is a 64-bit value. We don't actually have to initialize a variable the moment we declare it, although it's probably a good thing if you can, that way you won't forget. If we chose to, we could comment out the rest of this line, and as long as we complete the line with a semicolon, that would simply declare the variable, but then wouldn't do anything with it. So I'm going to leave that as a variable declaration with an assignment. Notice the naming convention for variables in Java is that we start with a lowercase letter, and then if we have a join in words, so in this case we're saying a byte, the start of the next or subsequent words, we actually use a capital letter. The literal formats we have here, if you simply go straight into the declaration of numbers, 127, then the number will normally be assumed to be decimal. But if you start with a leading 0, as in this case, then the number will be taken to be in base 8 or octal. In that case, of course, you can't have any digits that are greater than 7. We can also declare literals in hexadecimal. So in this case, with the leading 0x, I can start using hexadecimal digits, which of course are 0 through 9 and then A through F. In addition to integer types, we also have floating point numbers in Java. And the floating point numbers that we have are the float type and the double type. Float will actually use 32 bits for storage and double will use 64 bits for storage. So double is significantly wider range and higher precision, but float is often enough. The literal formats for floating point types are basically anything that has a decimal point in it, or anything that has an exponent expression, something like that, e plus 99. And by default, if you simply have a number of this sort, it will be assumed to be a double value. If you want to explicitly say that this value is a float type, the smaller type, then you can use an F suffix. Actually, uppercase or lowercase are both acceptable, but it's usual to use uppercase letters in these situations. You can also describe a double explicitly with a D suffix. Again, capital would be normal, but this of course is unnecessary since the default is double. Java also provides a variable type for characters. Character being a single piece of text. Characters are actually represented as 16-bit unsigned numbers, and they are represented using the Unicode character formats. That means that Java can work quite comfortably in most languages around the globe, not just in languages that use a Roman or ASCII alphabet. The character type is declared as type char, and the normal format for the literal is to use single quotation marks, not the double quotes. They're used for string types. And then to specify the character inside of it. So here we have the character uppercase A. There are actually other formats for character literals as well. because we might be representing characters that are not available to us on our keyboard if we're dealing with a Unicode environment, we can actually explicitly state, in this case, I want the character represented by the Unicode character 41 hexadecimal. So this is a hexadecimal literal. It has exactly 4 digits after the \U. And it turns out that character 41 is actually an uppercase A anyway. We also have, borrowed from the C programming language, a number of other constant declarations. In this case, \N is for new line. There are more of those, and you can look them up in your own time. The final variable type is the Boolean. Boolean is used in Java to represent logical values of true or false. That's the only 2 values it can have, so it behaves effectively like a 1 bit of storage. The literal values are true, all lowercase, or false, all lowercase. Unlike some other languages, you can't substitute other values where a Boolean is expected. So you can't say, for example, that a non-zero value represents true and a 0 value represents false. We have explicit true and false values, and we have an explicit Boolean type. So, we've taken a look at the declaration of variables, the initialization of variables, the types of variables that Java provides, and the naming convention that we use for the variable names that we are going to declare those variables with.